Hello everyone, welcome to my channel Cloud and Data with Koshi. So today we are going to see that the prediction on test data set, right? So we already have covered our model with the XGBoost. We already have done that XGBoost model creation. So now the time is that we have to create our testing part. Okay. So without any delay, let's get started. So I hope I am audible, right? Okay. So without any delay, we can let's start. So you can see we already have covered lots of things, lots of concept in this data set. And now the time is that we have to create the prediction part, right? So right over here, is data set using XGBoost. So now that this session we are going to predict, we're going to create the prediction on my test data set, right? So preparing the data set, preparing my test data set. We have to write preparing the test data set. What I'm going to do, I already had this test data, right? So I can write test data and we can also see the test data columns and how many rows are there. Just take two rows over there. And this is my actual test data, right? Now we have to drop some columns over there because these columns are not required. So write test data. Here you can write update the test data set with removing some columns. Okay, so test data is equal to test underscore data dot you have to drop some columns. Three columns. That is your these are the columns that I don't require. I already have columns name, so we have to remove these things from my data set. So I already have created. You can see this is my yes. So this is the data set. We have to remove these columns. So copy this line and just paste, and rest of the thing I'm going to do here. So this is the columns name that we don't require for that. So the command is or script is that you can say drop. So before execute this command, what I'm going to see, just check that how many rows and columns are present in my test data set. Okay. So test underscore data dot save, and you have to execute and 4209 in the original test data set, right? 4209 rows and 377 columns. Now you have to drop some columns, okay? Execute this cell. Now again you have to check. Now again you have to check the rows and columns. So test underscore data dot save, and then you can see this column. So 7, how many columns we have removed? 377 minus 365. That means 12 columns we have removed. Okay, that is successfully removed. So this is not required. And also you can check first 5 rows. Also you can check first 5 rows of your data set. Test underscore data dot head. Okay. As of now, we have done. So now you can see 365 columns and 5 rows. And is there any null values are present or not on the test data? We also check is there any null values are present or not. We have to check these things. So test underscore data dot is null dot sum dot any. Okay, so that false. There is no as kind of null value. Right? Now you have to use the label encoder again. So already we have added the label encoder. So again I have to add for getting all the codes from here. Again I have to add label encoder because the all code block you can get from this current cell. Otherwise you have to scroll up and down. You have to scroll up and down for getting that. Okay, so I'm again writing. That is the reason from sklearn dot pre-processing is pre-processing dot pre-processing, and you have to import your label encoder. You can see very simple label encoder. Label encoder, okay? So, and now initialized. Now you have to initialized your label encoder. So LE is equal to your label encoder. This value you have to add. Okay. So your label encoder part is done. And you have to check the type of this label encoder. You can also check the type of your label encoder. Once, so write type and you can write area. And this you can see it's coming from sklearn.preprocessing dot underscore label encoder. Okay, so that is this label encoder we have to import from sklearn.preprocessing. So you can also check from the sklearn official website. They already discussed this thing and you can get. Okay. Next task, what we have to do? We have to drop the ID columns. We have to again drop the ID columns. You can see the ID columns is there, right? So in the test data dot head, you can see the ID column is there. We have to drop this again. Yes, we have to drop this again, and you can write test underscore data underscore feature, and you can write test underscore data dot drop, and you have to remove the columns ID. Okay, and you can print test date the after remove first you have to execute this. Okay, so you can write drop the column ID. Next, what you have to do, you have to check the its shape. So you can write print test data feature dot shape. Okay, and you can see 4209 rows and 3 columns are there. And you can also check the head. So test data feature dot head, and you can also check these things. So ID will not be there. So now you can check the ID and ID columns we have removed. To check the first 5 rows and also check the ID column is removed from this test underscore data underscore feature dataset. Okay, so up to that we have done. Now we have to check that 5 point summary. Those data that the D type is object. First we have to check the data type. First we have to check the data type, right? So first we have to check the data type. You can write test underscore data underscore feature dot D types. Okay. So you can see the data types are mixed over here. Object, integer, right? So you have to check only the object data types and its 5 point summary. You can write check 5 point summary whose D type is object. Okay. So you can write test data feature. You can write test data feature dot describe include is equal to object and use press Ctrl Enter. Now you can see this is the columns, right, where data is object. Now you can see count, unique, top frequency, the 5-point summary of the data set, right? Now you have to create the label encoder. Already label encoder you have create. Now we have to transform. Now we have to transform with label encoder. Okay. So write test underscore data underscore feature and x. This is the first column x0, right? And you have to take le dot fit transform. Yes, fit transform and your test underscore data underscore feature dot x0. This is the column. Just copy over here and paste. Okay. So do for the same thing for rest of the columns. X1, you can write X1, copy this line, X2, you can add X2 over here, copy this line, simple thing, just write X3, here you can write X3, copy this line, you can add X4 and here you can also add X4. So this is the columns where that label encoder is there, right? So you can see A, J, T, A, J, V, T, and up to X8. Okay, so you have to convert it in the numerical form. Okay, I hope you can understand. So X4, now copy and X5, that also be X5. Just copy this thing and that will be X6 and also X6 and X8. X8. So just write X8 over here. Okay. Now execute the cell. Either you can click over there or you can press Ctrl Enter. And your cell is executed. Okay. Now you can test these columns and convert it or not. Now you can check this all above mentioned column is converted or not. What I'm going to do, so test data feature dot head and just take 2 rows for the testing purpose. Yeah, you can see it's converted 21 up to x8, right? 0, 26. So that is done. So my label encoder is successfully working in my test data feature, right? Test data set. Now you can check its rows and columns. Now you can check its rows and columns, right? So you can write test data feature dot save and your save is ready 4209. Okay, and you also check the data type value counts. Now we can also check the D types value count. We can write test underscore data underscore feature dot D type dot value count COUNT, and you can check the value counts. Okay, so test data feature test underscore data feature dot D types and your dot value counts. Okay, and you have to add the principal component analysis. Now you can initialize with PCA. But you can write PCA dot fit. You can fit your data with PCA. So PCA dot fit and your test data feature you can fit. Okay. So just add PCA dot fit your test data feature and use Control Enter. So your PCA component is ready with the test data set, right? Next thing what I'm going to do, if you have any doubts, so please let me know. And now you have to create the transform, right? Now we have to create the transform. So test underscore data underscore feature underscore trans is equal to PCA dot fit transform. You can use fit transform and your test underscore data underscore feature. Just execute and you can check the shape on this newly created transform, right? Now we can check the test on newly created transform data with PCA fit. With PCA fit, right? So you can write print test data feature trans dot shape. So that is done. And you have to also print if you wish. So I am showing these things also. You can print your test underscore data feature trans. Okay, and also check you can check the data set the transform. Okay, and the data type, okay, it's ND array. You can see, just copy and paste here, just create the control and it's a ND array of numpy. So that means if I write dot head method, that time it will create the data type structure. Now it's coming in the array structure, okay, ND array structure. And you have to create the prediction now. Now we have to create the prediction. So what I'm going to write, test underscore print is equal to your model was there dot predict is model predict, and you can write test underscore data underscore feature underscore trans. Okay, and now you can print your prediction on the test data set, right? The prediction is coming. Now I am going to create two distribution plot. Now going to create two distribution plot. Okay, you can write fig axis plt dot subplot 1,2 fig size is equal to this value 25,9. And you can write train underscore plot is equal to your SNS dot test plot. You can write train underscore data target train underscore data underscore target less than 250, and you have to create the pins is equal to 250 ADA is true. Okay, now write train underscore plot is equal to and dot set underscore x level, and you can write target train data. Okay, weight that is bold and size that is 25. So this is the x level I'm going to set. Okay, copy this line and paste, and for that y level and write y level, and this is the distribution. This is the distribution. Weight bold, size 25, and you have to create the title. Now copy and set title. Set title, and you can write list of target for train data. Okay, just font weight. This is font weight. Weight means weight that is bold and size that is 25. And you have to create the test plot, test underscore plot is equal to SNS dot test plot. And you have test underscore data, test underscore prediction data is there, right? And you have to create test spread. Just take certain amount of time. This measure, this condition, okay? 250, create the bins. So it will equally distributed within the group of data with the bins, right? And you can create GDE, that is true, and your axis will be AX equal to axis 1. This value. And same thing, the test plot, you have to create the copy this line. Train plot is ready now. Train plot code and your test plot. Your test plot code, okay? X level, you can just change target test data, not train data, okay? Test data, it bold and if you copy this line, distribution part, copy this line. Sorry, you have to change this also, test plot. Dot X level is test plot. And just copy this second line, Y level. And just paste test plot, Y level distribution, width and size, and you can use the set title. Copy this line, paste it, copy the test plot, set title, you can write test of target for test data, not train data, because train data already done. Test data, weight bold 15, and you can plot it. Now all the data you have to add it. Now we can plot our distribution. Now we can plot our distribution distribution. You can write plt dot type underscore layout. Okay, and just click the save. So everything is ready. I think it'll take some time. Limited distribution is not 1 minute. Now we have to we have ready our train plot and test plot, and we have to add some adjust this layout. Okay, so adjust the width space between these subplots. Okay, and you can run. What we have to see now, you can see the target and the train dataset distributions are coming, right? Okay, these two dataset distributions are coming. We can say it's a pictorial view comparison between my target for training dataset and predicted target for testing dataset. You also can write this thing. It is the pictorial view for comparison between target for training dataset and predicted target for testing dataset. Okay. We can make one conclusion for that. My training and testing conclusion, these two comparison we can see, right? On my target or train data and target my test data. This is the distribution. And you can see it's kinds of a bell curve, not totally bell curve, but it's creating the shape of bell curve, right? And it is distorted. This is not that actual bell curve. It's a left skewed part is there, okay? And you can see this is the code. First, you have to train your plot with that label. You have to add your X label, Y label, and this is your train target data that is less than 250, and you have to create the bins. Okay, KDE true, and you have to add your axis. AX first axis 0 and second is axis 1. Okay, so we are done with this code. Okay, you can see. So if you have any doubts, please let me know. I have covered the entire that problem statement of this. And if you have any doubts, so please let me know. So we have done completely that this problem statement, whatever the task is there that I have already completed. So you can check my GitHub repository for there, and I will add my GitHub repo link with this description box of the video. And if you have any doubts, so please let me know. I have to update some code over there because here I have to update some code and I will update this GitHub repository. Okay. So all the tasks I have completed, following actions will be performed like apply label encoder, perform dimension reduction, and predict your test data using XGBoost. So we have done all of the things in my problem statement. If you have any doubts, so please let me know. This distribution chart code also be there. You can take a look from it, and I also update this entire GitHub entire IP1B file in my GitHub repo, the updated version. Okay, so I am also write the updated version. So two files will be there. You can check. You can suggest. I can suggest this file updated version. Okay. So thank you for joining the session and thank you for being with us. If you have any doubt, please let me know in the comment box. So we can definitely concern and your problem, and I will try to address your problem. And thank you for joining the session. Thank you. Thank you, everyone.